Hello everybody, welcome to day 18 of Advent of Code 2022. I decided to skip day 17 for now because it seems to be, based on the statistics, to be a longer or more complex problem to solve. So I will solve day 18 today instead because I'm a little bit short on time. So okay, so boiling boulders. In this problem, we will be working with some boulders. We'll be scanning some lava droplets, and because the lava is moving fast, the resolution is quite low, and we approximate the shape with 1 by 1 by 1 cubes on a 3D grid. So each cube is given its XYZ position. We need to count the number of sides of each cube that are not immediately connected to another cube. So if we have two adjacent cubes, we need to count only their there are two adjacent cubes have total of 10 sides of surface area, which seems to be it might be quite much easier than the previous problem with recursion and so on. So let's see, I will copy the input and put it, of course, in the input file. And because it's a three-dimensional point, let's create a new point structure, point 3D. I will rename it this. Oh, well, replace this by point 3D so that we can work with 3 dimensions, just like that. Of course, needs some additional adjustments, like we need Z coordinate, and we also need to adjust these. So a Z plus Z, it's done. And then we need a Z minus BZ. We will not probably be using this in this problem, but while we're at it, it's better to do it, not to cause us any trouble in the future when we try to use it and it will not work correctly. So yes, so if z is equal to 0, then we do this. Tuples. Okay, so that's this one. Of course, int c. Right, this. And Manhattan distance is ABS c minus bc. And that should be all we need. Okay, so we have the points, and now let's add it as a reference. We will be reading from the file, so seems like our copilot is not yet woken up. Oh, it's back now. Nice, nice. Okay, so we will split the line. So for each, points, cubes. Point 30. So each cube will be represented as a three-dimensional point, and we'll be just parsing the line. So split the line by commas, and then we will parse it. So cubes, add new, and now we will do point. Well, that was it, maybe. Yes, exactly what Copilot suggests. So we parse the coordinates, and we have the points read. And now, how do we determine if two cubes have a common side? handle this. So two cubes have a common side if they are adjacent to each other by a side. That means that when one cube is here, the other has to be right next to it here, 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 or here, or here, or here. So always one of the axes of the cube has to be the same as the axis of the other cube. Does it make sense? Does it hold true? I think it should. Well, no, not one, but two axes have to be the same, and one is different. So if we have, in this case, 1, 1 is the same, and 2 and 1 means that the other cube is shifted in one direction, so to speak, and that seems to make sense to me. So two axes have to be the same and one different. Okay, so we can create a method which will say this, and this will tell us if 2 points or 2 cubes are adjacent, and we will do it like this. A equals so there will be multiple cases. So ax equals bx and a y equals by. So these two are the same, or a x equals bx and a z equals bz. So we have this option. Then we have the option where a y equals by and a z equals bz. That should be the 3 different cases which we need to consider. And if one of them is true, then the 2 are adjacent. And now, when we have the cubes red, we can determine for each cube how many are adjacent to it. And there's not that many cubes, so I think we can go like n by n. So for each cube, determine how many are adjacent to it one by one. So okay, so for each cube in cubes, we will count the open sides. So 0. At the beginning we have 6 sides on the surface, and then we will go through through all other cubes. So if other cube is equal to cube, because we don't want to match against it, it's against itself. And now if are adjacent, other cube and other cube, open sides minus minus, and the thing is we want to short circuit this. If open sides is 0, there is no need to try the other ones because we already know that there is no side to be adjacent to, so we'll break. And so finally, surface area will be plus cos equals open sides. Now, we will be checking unnecessarily twice the same combination because we will checking a cube against all the others, and then when we check the others, then we will check against the previous one again, which kind of is inefficient, but in this case I think there's not that many cubes, so it shouldn't matter and shouldn't mean that the program would run too long. So let's try surface area and write it. For this 6 is too little. Okay, why is it so few? We have 6 sides for each cube. Does this work? Yes, it seems to work. So for the same cube, we will not check if there is a problem there. So if they are adjacent, we remove one side from the numbering. So does this check work? So we have x and y, x and z, y and z. This makes sense. So surface area input file, let's see. So it's 36, that's not enough. Definitely not enough. Why is it not enough? Let's see. Let's see. Sanity check. I will have these two. And that should give us 10. If I'm not completely wrong. Show me. So it's here, we have 0. And let's see. This should give us 10. Yes. So where do we go wrong here? So the first one, let's see how many sides does it have open. So the first one has 0 open sides. So 2, 2, 2. 1, 2, 2. So this one is total area. So what could be wrong here? A 0 for this one. Three for the second one. 3 for the other one. So 2, 2, 2, 1, 2, 2. There's 1, 2, 3, 4, 5, 6, 7. Ah, what am I doing? Of course, it's this. It's not that easy. So this check is not enough. We need to also check if the last coordinate has. Yes, this is exactly the check we need. If the last coordinate has its difference at most 1, because otherwise the cube will be in a completely different place. So that was the problem I was missing here. Now it's 64, which is correct. And let's see the full input. This was a kind of a lapse of judgment in the logic. So it's 4,456. And let's see if that's correct. And that is correct. Okay, so we have the first part done. And now the second part. The cooling rate depends on the exterior surface area, but calculation also included the surface area of air pockets trapped in the lava droplet. Okay. Now we need to scan the exterior area of the droplet. Kind of removing the interior one. So how do we determine what's inside of the droplet? How do we determine what's inside of the droplet here? We need to find... We need to search the space for cubes which are within that's interesting. Interesting problem where we Alright, so how do we determine what's inside of the droplet? We need to do kind of a breadth first search to determine that, I think. Because otherwise we will not be able to see that. So how do we determine that? So for each of the exterior sides, we need to figure out whether we can get from there to somewhere outside. Because if not, we are surrounded by other cubes. So for each of the six sides of each cube, we need to see if there is another one on right there, and if not, we will kind of do a spreading where we will see if we can flow from there to the outside. So let's think about this a little. I will use the simpler example here. Let's see, 0, 0, 0 is not there, so we can use that as a kind of anchor. So there are 6 directions where we can go. Let's do it simpler. So like this. Yes. So X. Oh, right. It's that's not right. So the direction. These ones are actually diagonal. No, that's right. These are fine, but these are not right. So we need to have -1, 0. -1. Okay. So these are the directions that we can go through. And now we will need to determine the minimum, maximum coordinates of all the points. So let's do it there. So x value, y. So this is max. Now we will mark those. So let's store the point here. So point 3D. We will store that minimum as point x, min, y. Just so we can find the boundaries of the shape, the outer boundary. Like this. And now the same for maximum. So this will be max and min max. Right, so this way we get the maximum and minimum boundaries. Now what we also will do is -1, so we actually have an outer boundary, not exact boundary. +1. See. Okay, so now we will go from each of the cubes to all its 6 sides. And from each side, we will try to see if we can get by stepping in breadth first search kind of way, if we can reach the boundary. And if we can do that, then the side is a exterior side. So I will make a tool. Interesting. Let's see what this suggests. Basically, what we need to see if we'll have a queue. That will enqueue side. And while queue count is bigger than 0, then we will see if the current point is blocked. If it's blocked, we just continue. And if current is less than or equal, or greater than or equal, greater, basically if we in any way reach the boundary, then we return true. And if we don't find any solution, then we return false. Is this correct? I think it should be. We will be... Well, we will be returning to the same areas again, so let's mark hash set. Let's get the hash set of 0.3d, which will be like the visited areas that we already saw. So add the current one. So if cubes contain the current point, then we continue by, while dequeuing the point. Or visit, no. Now we should enqueue all the directions for each directions without diagonals 3D. We will point this one. We will check if we already visited, and if not, then we will enqueue it. And this way, we should be able to kind of quickly flow through the area to see if we ever can reach the boundary. Right, so let's see if this works, or I missed some breakpoint here, there, or something like that. I have input, the simple input. So let's see. $58, that seems to be promising. 58, okay. So let's see if the big file will also adhere to this. Oh, this will take longer because we're stepping through many cases and basically flowing through the whole area, but it should be done soon. Let's see where we are. Ah, that doesn't seem nice. Seems we're somehow looping. Whoa, that's a big area. So there must be some kind of mix-up. Minus 22, 22, 22. Of course, I'm not. Or I am marking the visited ones as visited. The area is not that big, so it shouldn't be taking too long. Not sure why it's adding so many points into the queue. It's 22, 22, 22, if I'm not mistaken. So maybe the hash doesn't work? Let's see. let's just add else and see if we ever hit this. But we should. It's a record, so I don't see that happening otherwise. I'll let it run for a while so that we have some bigger set. So now the queue contains a lot of items. Right, we can. Right. We need to make sure we don't demark the visited ones here immediately, because otherwise we will enqueue them multiple times unnecessarily. And I think that should be what we need. Again, very many. A lot of points there. So, what is wrong? So the maximum X, Y, and Z are 22. So the total area should be at most this. And there is already more items here. So why? Why are there so many? Pretty sure I'm missing something very, very basic. But what is it? What is it that I'm missing? Okay. This might be quite important. I need to add the visit new point as the visited one. But still. Okay, that's less. Right, now it seems to be running. Alright. Let's see. So far so good. The numbers are much lower. And we are hitting this quite fast, so not a problem so far. So let's see if when this finishes, so what's the final number. I guess not probably is the most efficient solution, because it's traversing the whole 3D space multiple times, and we could probably mark the interior ones while we are at it. But, well, this should be the correct solution, hopefully. And it is. Okay, so a better solution would probably be to mark all the interior ones. So for maybe what we can do is just to see if we can speed it up. Interior. I can do this. Then when we a second. Right, so we can mark the visited points as interior, and even mark the ones that we know that are exterior as exterior. So if it's exterior, then we can return immediately true. And if it's interior, we can immediately return false. So we can add the visits as exterior ones, and here we can also add visits as interior ones. And this way we might cut off most of the time of the calculation. Yes, and we did. So I think that solution is much faster. Well, it definitely is much faster. So, okay, that's it. All right. So thank you for joining me for day 18 of day 18 problems of Advent of Code 2022. I'll push day 18 into my GitHub repo, and I will be back with the other problems that are awaiting me. The scary problem number 17, and of course the others that will be unlocked by the time when I get to it. So see you next time, and have a great day. Keep coding, and make sure to subscribe if you want to be notified about new videos. Bye bye.